This is the final project, Esterification application in food science, made by Ron Young. General knowledge of esters. Life approaching. We use esters as flavorings in food or fragrance. A common example is banana oil. In industrial uses, we use esters as organic solvents, polyesters, fabrics for clothes, and nitroglycerin, ingredients of an explosive bomb. In chemistry approaching, ester is composed by a carbonyl group and an alkoxy group. It is slightly soluble in water. Mostly it dissolves in organic solvents such as THF or ethanol. When using IR spectra, esters has a sharp peak among 1730 to 1500 wave number. Ester synthesis mechanism. Let's use methyl butanoids and apple flavoring as an example to perform synthesis mechanisms via Fischer esterification and Mizunobu reaction. In Fischer esterification, reagents include butanoic acid, methanol, and sulfuric acid, which activates the esterification here and catalyze the process. Finally, we get the ester plus water as final products. Overall, it is a nucleophilic acyl substitution reaction, known as NAS reaction. Let's have a look at the detailed mechanism here. So first, we protonate butanoic acid. Secondly, methanol attacks the carbonyl carbon to make a tetrahedral intermediate. 1, 2, 3, 4, the TI. Third, we deprotonate the new added methanol. Fourth, make the OH group from a butanoic acid into water, which later acts as a leaving group by protonation. Water leaves and reforms the carbonyl pi bond by deprotonation in step 5. Six, the last step, we have the methylbutanoate forms. Here is another alternative method in producing methylbutanoids, the Mizunobu reaction. Reagents include butanoic acid, methanol, and DEAD, diethyl acyl dicarboxylate with PPH3. DEAD. Yeah. At the end, we only get the desired ester as final products. Overall, it is a Essantil reaction. Let's have a look at the details here. So first, PPH3 attacks that. PPH3 attacks. And it is a nucleophile attack. In the second step, we produce a 3-der ion intermediate with plus charge and negative charge. To A, the lone pair from the negative charge nitrogen deprotonates the butanoic acid, which activates our nucleophile here. The nucleophile. A lone pair on O atom from methyl attacks the positive charge P, making a potential leaving group in the following steps with conjugated base. So into B. And this is the potential leaving group. Third step, deprotonation of butanoic acid by the previous N from that. Fourth, a lone pair from the negative charge O of the new butanoate attacks the CH3 and breaks the CH3O bond. And methylbutanoate forms in the last step. So let's compare both esterification reaction. In Fischer esterification, catalyst is sulfuric acid a strong acid catalyst. In Mizunobu reaction, there are PPH3 and DET, and these are neutral catalysts. Reaction speed, Fischer esterification may take 1 to 10 hours, but in Mizunobu reaction, it only takes 1 to 2 hours. Reaction condition, Fischer esterification requires heat up to about 60 degrees Celsius or more in ethanol as solvent. Mizunobu reaction does not require heat but ice bath to about 0 degrees in THF. Pros for Fischer esterification, it is relatively simple compared to Mizunobu reaction, and water is the only byproduct. Pros for Mizunobu reaction, it is a mild reaction condition based on the neutral catalyst. And it is high energy efficiency since it does not require long time heating compared to Fischer esterification. It only requires ice bath. Cons for Fischer esterification, as I mentioned earlier, it requires long time heating. Also, it requires strong acid catalyst, which is hazardous to us. Cons for Mizunobu reaction, it is relatively complex compared to Fischer esterification, with some uncertainty in gaining the desired ester. Let's talk about the application in food manufacturing for esters. Ethyl acetate in winemaking. The esterification happens in the bottle aging process, but before that, we have to gain alcohol and carboxylic acid to do esterification. So first, yeast consume sugar into carbon dioxide and ethanol. Some ethanol undergoes reduction and becomes ethanol. Other ethanol undergoes oxidation to form ethanoic acid. Now we can have ethanol to and ethanoic acid undergoes esterification and forms ethyl ethanoate. And this is where aging process started. And you can start to feel the pleasant smell from the wine. And that is the ethyl ethanoate. And another ester, paraben, acts as food preservatives with antimicrobial effect. Synthesizing paraben involves 4-hydroxybenzoic acid with desired alkyl groups, and we can get desired alkyl paraben after that. Some facts about paraben: it is widely used because of good solubility in water, which does not alter any properties of the product. Also, it is colorless and odorless. The longer alkyl group paraben has, the better antimicrobial effects it has. The green chemistry of esterification. These are the 12 principles of green chemistry, and these are just the things we should keep in mind when designing science experiments. Earlier, we mentioned that Fischer esterification is energy inefficient with long time heating, and strong acid catalyst uses, which is hazardous chemical to us. So that introduced a greener way in producing ester. The microwave-assisted esterification, also called as MAE, and ion exchange resin. The mechanism is by using microwave radiation to increase the movement speed of molecules, which causing a lot of collision and ends up with generating great amount of heat for heating up. And associations with ion exchange resins as catalysts to replace strong acid catalyst sulfuric acid. Also, ion exchange resins are reusable after washing them with hexane. In the research, MAE carried out 99% yield of esters within 2 hours reaction period and least energy consumption overall compared to other heating up method. So based on that, MAE is energy efficient, while ion exchange resin is a safer chemical compared to strong acid catalyst. Let's wrap it up. After discussing synthesis and application, there are more things that we should know. Ester synthesis methods are various and controversial. As a group of carboxylic acid derivatives, there are tons of ways to obtain esters efficiently, but the mechanism details are somehow unclear for most of them. Like Mies-Noble reaction, it is still controversial in its mechanism and its intermediates. Other than natural esters, most synthetic ester safety is highly doubted. Like pyridine as preservatives, it has an unclear association with breast cancer. Lastly, food flavoring is only a small portion of ester application. Primarily, it applies in cosmetics and other carboxylic acid derivatives synthesis. These are the references. And thanks for listening.